Welcome back to Mrs. Law's class. In this video, we're going to take a look at dividing rational numbers. Now remember that dividing integers has sign rules, and the sign rules that apply to integers also apply to rational numbers. So when we're dividing, if the signs are like a negative and a negative, or a positive and a positive, when we divide, the sign answers will be positive. And when we divide a negative and a positive, or a positive and a negative, the signs will be negative. So if we take negative 20 divided by 5, we're going to get negative 4. And negative 27 divided by negative 3 is equal to positive 9. So let's take a look now at dividing decimal numbers. So without a calculator, we're going to have to do long division. So we have negative 5.4 divided by 3. The second number is the number that is trying to go into 5.4. And we want to know how many times this happens. The 3 is what we call the divisor. And the 3 goes on the outside. And the 5.4, we're going to ignore the sign for now, is called our dividend. And that goes inside our division symbol. So 3 goes into the 5 one time. And then 1 times 3 is 3. We're going to subtract. And that gives us 2. And now we have 24. 3 goes into 24 8 times, and then 8 times 3 is 24, and we subtract, and we have 0, and that's our remainder. So notice that our decimal is here at 5.4, so we're going to place that same decimal, we're going to place the decimal, in the same place right above, and that will be 1.8. So negative 5.4 divided by positive 3 we'll have a negative answer, and it'll be negative 1.8. All right, let's try another one. So in this question, we have a decimal number divided by another decimal number. So our divisor, again, is our second number, so that's our 0.4. That's going to go on the outside of our division symbol. And then the 6.7, our dividend, goes in the inside. Now, because the number, our divisor number, has a decimal, we're going to move that one place over. So we're going to make this 4, and because I made our divisor number move the decimal one place to the right, we're going to do the same thing with our dividend. So we're going to move the decimal to after the 7. So now this will be 67. All right, so now 4 goes into 6 one time. 1 times 4 is 4, and we're going to subtract, and we get 2. And then we're going to bring down the 7. 4 goes into 27, 6 times. 6 times 4 is 24. We subtract, and we get 3. All right, so we're going to need to get some more numbers so that we don't have let's see if we have a remainder. So let's put another couple of zeros, and we're going to bring down the next, or the first 0. And we now have 30. So 4 goes into 30. 7 times. 7 times 4 is 28. And we subtract. We get 2. Bring down the next 0. And we get 20. And 4 goes into 20 5 times. And if we multiply, we got 5 times 4 is 20. And we get 0 for our remainder. So notice that the decimal is after the 7. So we're going to bring that straight up and put it between the 6 and the 7. So here, negative 6.7 divided by negative 0.4 is actually going to equal this number here, 16.75. All right, so that's how we divide decimal numbers. So let's go on to dividing fraction numbers. Now, to divide fractions, we want to make sure that we keep the first fraction the same, so we don't do anything with it, but recall that we multiply by the reciprocal. So we're going to say the first fraction stays the same. The division symbol, we're going to change it to multiplication. So change it to times. And then 9/10, we're going to write that as a reciprocal. So we're going to change this to negative 5 over 7 times 10 over 9. And we're going to now treat this as a multiplication question, and we're going to multiply straight across. So negative 5 times 10 is negative 50, and 7 times 9 is 63. Now, note, remember to change mixed numbers to improper fractions if you have any mixed numbers that you're working with, and to write whole numbers as fractions over 1. And a very, very important note is that fractions can only be reduced when multiplying. And the reason that happens is because when we divide, we're actually going to have to flip. So the denominator that you want to cross off with the numerator, like let's say it was 5 and 10, actually doesn't happen, because when we divide, remember that we are multiplying by the reciprocal, and the 10 will actually become in the numerator, and the 9 will become in the denominator. All right, so let's take a look at some examples here. So let's calculate or evaluate, and we're going to reduce our answers to simplest form or lowest form. So we're going to take this and we're going to make it into negative 5 over 7, and this is going to change to times, and then we're going to go 7 over 6. So now we can check if we can reduce any numbers, and yes, we have a 7 in the numerator and the denominator, so they're going to become 1 when they reduce. So our answer for this first one is negative 5 over 6. All right, so the number 2, looks like we can do lots of canceling, like the 10 and the 15 and the 4 and the 12, but remember, we could only cancel when we're multiplying, because when we divide, we need to change it to multiplying. So you actually wouldn't reduce until you have it in this form, and now we can reduce. So we can say that 2 goes into both 10 and 4, so the 10 becomes 5, and the 4 becomes 2. And we also can see that 3 goes into both 12 and 15. So 3 goes into 12 4 times, and 3 goes into 15 5 times. So now that that's reduced, we now have negative 5 times 5, which is negative 25, and 4 times negative 2 is negative 8. Now, because both of these numbers are negative, we can actually erase the negative sign, and we have 25 over 8. All right, in our next example, we have 4/5 divided by a whole number. So let's help ourselves by placing the negative 6 over 1. So this is going to become 4/5, and we're going to multiply, and we're going to multiply the reciprocal of negative 6, which is then going to be negative 1 over 6. And we can reduce. So 2 goes into both 4 and 6. So this reduces to 2 and 3. And then we're going to multiply 2 times negative 1, which is negative 2. And 5 times 3 is 15. All right, so same thing. Let's place the negative 8 over 1. Now remember, we're only taking the reciprocal of the second fraction. So we still have negative 8 over 1. But we're going to times this now by negative 12 over 7. So when we multiply, we're going to get negative 8 times negative 12, which is 96. And 1 times 7 is 7. And I want to leave this one in improper fraction. All right, 2 more. In these last 2 here, we have some mixed numbers. So recall that when we multiplied mixed numbers, we had to change them to improper fraction. So the same has to be done when we're dividing mixed numbers. So we're going to go 6 times 2 plus 1. So it's going to be 13 over 6. And remember, this is going to be negative 8 over 1. So let's place the 1 underneath. So division is going to change to multiplication. And the negative 8 over 1 is going to become negative 1 over 8. And we can't do any reducing because 13 is a prime number, which doesn't go into 6 or 8. So 13 times negative 1 is negative 13. And 6 times 8 is 48. All right, last one that we're going to work on together. Change both of these numbers to improper fraction. 5 times 1 plus 2 is negative 7 over 5. Remember, we don't take into account the negative when we are changing into an improper fraction. So the negative is just placed there at the end. And I'm going to do an extra step. So I'm going to have division still. So in this step, all I'm doing is changing my mixed numbers to improper fraction. So 4 times 2 plus 3 is 11 over 4. Now I'm going to change this to multiplying by the reciprocal. And nothing can reduce. So negative 7 times 4 is negative 28. And 5 times 11 is 55. And we can't reduce because 7 doesn't go into either 5 or 11, and 7 is a prime number, and 4 is an even number, and it doesn't go into 5 or 11, and 2 doesn't either. And that's how we divide fractions. All right, we're going to finish off with a couple of word problems just to show you how to interpret these. So we're going to write a multiplication or division mathematical statement to solve these problems. So Mrs. Law sits in a 400-seater plane to go to Disneyland. If the plane is 3/5 full, how many people are on the plane? So let's circle our important numbers. We have 400 and 3/5. Now it's 3/5 full, and it's 3/5 of, I'm going to write this in words. So it's 3/5 full, and normally full is 400 people. So 3/5 of 400 means that we're taking a part of 400. In math language, that means we're going to go 3/5 times 400. So in this example, we can reduce. 5 goes into itself once, and remember this is going to be 400 over 1. So 5 goes into itself once, and 5 goes into 400 80 times. And when we multiply, we get 3 times 80, which is 240. And then 1 times 1 is on the denominator, which we don't need to write. So how many people are on the plane? There are 240 people on the plane. All right, in this next question, while in San Diego, Mrs. Law notices a temperature increase of 18.6 degrees Celsius over a 4-hour period. So what was the hourly increase in temperature, assuming the increase is the same each hour? So the important thing is that every hour is the same. And our question is, what was the hourly increase? So we're going to take our 18.6 degrees, and we're going to divide it by 4 so that we can figure out what 1 hour temperature's increase will be. So because we're dividing, we're going to have to do a little bit of long division. So we're going to place 4, our divisor, on the outside, and our dividend, 18.6, will go on the inside. So 4 doesn't go into 1, but 4 does go into 18 4 times. 4 times 4 is 16. And we're going to subtract. 18 minus 16 is 2. Bring down the 6. 4 goes into 26. 6 times. 6 times 4 is 24. Subtract. And we get 2. And we need to bring down another 0. So we're going to add a 0. Bring that down. And 4 goes into 20 5 times. Now remember, this is a decimal number, 18.6. We're going to bring that up here to be 4.65. That means the hourly increase was 4.65 degrees Celsius per hour increase. And that's how you solve a couple of rational word problems.